Well, hi there. So for this video, we're going to do something that is quite key for your success in this chapter. You're going to have to be able to identify the oxidation number of elements in a compound. So those rules, those oxidation rules that I gave you, they're kind of going to have to be second nature. There's not a whole lot of them in order for you to be successful in this part, this specific part of the exam. So the oxidation number is not their total oxidation number, remember, it's their individual oxidation number. So just memorize the rules, there's not a whole lot of them, and we're going to practice implementing them on, six practice problems that I picked out, or made up. So do I have a rule for K? I do. Remember, first column, first group are going to be +1. So that's easy. Oh, and I skipped a step, right? What's it have to total out to? 0, right? Because what's the total charge? 0 for my for the whole compound. So I don't have a rule for Mn, but I do have a rule for O. It's probably going to be -2, right? So if K, there's only one K, and he brings a total of +1 to the party, and oxygen brings a -2 to the party, each of them, and there's 4 of them, that's going to be a -8, right? What does Mn have to be for it to total out to 0? A +7, right? And there's only one Mn, so he's a total of +7 each. So then these would be the answers. I would say, what's the oxidation number of manganese in this compound? So you'd say +7. So how about for CrO3? All right, so there's no charge here, so it has to total out to 0. Nice. I don't have a rule for Cr, but I do have a rule for O, for oxygen. Typically it's going to be -2. Remember, I'm not going to give you an example unless, remember, O2 has an oxidation number of 0 by himself. But when oxygen's in a molecular compound, it's going to be a -2. So if there's 3 of those guys, they're bringing a total of -6 to the party. So chromium has to be +6. And it looks like there's only one chromium, so +6 it is. All right. So that would be the answer. Chromium's oxidation number for this problem is +6. Oxygen's oxidation number for this problem right here, or for this compound, is -2. Let's go down here. How about NO2-, nitrite? So this one has to total out to -1. You got it, because it is an ion. -1. I put a negative there. Sorry if it's a little small. -1. So it's a total out to -1 because that's the charge here. I don't have a rule for N, but I do have a rule for oxygen. It's going to be -2 most likely, right? Because I'm not going to try to trick you. So a total of -4. So what does nitrogen have to be in order for this to total out to -1? I believe it's a +3, right? Has to bring a total of +3 to the party. And there's only one of them, so each nitrogen is a +3. So nitrogen's oxidation number in this problem is +3, oxygen's -2. Let's move on to sulfate. So this has to total, the oxidation numbers have to total out to, you guessed it, -2. Now we're cooking, right? I don't have a rule for sulfur, but I do have one for oxygen. It's going to be -2 each, right? And so if there's 4 of them, it's a total of -8. So what must sulfur be in order for this to total out to -2? Sulfur must bring a total of +6, correct? So sulfur's oxidation number in this problem is +6. Let's keep going, shall we? How about H2S? So totals out to 0. I don't have a rule for sulfur just yet, but I do have one for hydrogen. It's going to be +1. Side note, remember, H2 by himself, what's his oxidation number? 0. Remember, because that's elemental. This is by himself. But we're not talking about him. He's in a compound here. He's in an actual compound with other molecules. So, +1. Total of +2. So sulfur must then bring a total of -2. And there's only one sulfur, so -2. Perfect. So that is sulfur's oxidation number and hydrogen's. Last but not least, let's determine the oxidation numbers of these elements. So it's going to equal 0 because it's not an ion, right? There's no ionic charge here. Don't have a rule for carbon, but I do have one for hydrogen. It's going to be a +1. So a total of +8 is going to be brought to the party because of hydrogen. Right? So carbon must then be a total of +8. But look, there are 4 of them. So each carbon, oh, sorry, -8. It's late. Let's make that a little bit more. -8. Total of -8 to the party, right? Because -8 + 8, 0. So, focus, there you go. So, if I wrote a -8 here and said each carbon is a -8, that would be incorrect. Because if each carbon was -8, there would be 4 of them, it'd be -32. Ooh, that's too much. But I need 4 of them to bring a total of -8. So how many does each carbon bring? A -2 each. You can always double check. -2 each, there's 4 of them, total of -8. +1 each, there's 8 hydrogens, total of +8, it totals out to 0. So the oxidation number of carbon in this problem is -2. So this is just a whole mess, a whole mix of them. So I do hope that this helps because we not only covered things that contain oxygen, things that contain the first and second group of the periodic table, but we also include ions and hydrogens, right? So good luck with that. This is very key in order to be successful for this chapter.